A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. You know, most people think of a database as just a piece of software you install and then promptly forget about until it breaks. But when you look at something like PostgreSQL, you're not just looking at a tool, you're looking at a 30-year miracle of human cooperation. Today's prompt from Daniel is about the governance and sustainability of Postgres. And honestly, it's the perfect time to talk about it, because we are staring down the release of version 19 in just a few months.
It really is a miracle, Corn. I was digging into the commit history recently, and it's staggering. We are talking about a project that has been actively developed since 1996. It has survived the dot-com bubble, the rise of NoSQL, the cloud revolution, and now the AI boom. And through all of that, it hasn't been bought by a giant tech conglomerate, it hasn't switched to a restrictive license, and it hasn't burned out its maintainers. By the way, fun fact for everyone listening. Google Gemini 3 Flash is actually helping us put this script together today.
Well, hopefully Gemini has the same uptime as a well-tuned Postgres instance. But seriously, Herman, the thing that blows my mind is the boring factor. In the tech world, boring is usually an insult, but for Postgres, it's a badge of honor. It's the backbone of the New York Stock Exchange. It powers massive cloud platforms, and yet it's run by a volunteer-driven community. How does a project that critical avoid the usual open source pitfalls? Most projects either get captured by a big company like MySQL did with Oracle, or they slowly wither away because the three guys running it from their basements eventually want to see sunlight.
That's exactly the tension the PostgreSQL Global Development Group has managed to resolve. My name is Herman Poppleberry for those who don't know, and I live for this kind of organizational architecture. The secret sauce is that there is no Postgres Inc. There is no single CEO who can decide one morning to change the license to a business source license because they need to beat their quarterly earnings. Instead, you have this incredibly robust, almost academic meritocracy.
Right, the core team. I remember reading that it's only 7 people. 7 people holding the keys to the most important database in the world. That sounds like a single point of failure waiting to happen, or at least a very stressful Slack channel.
It sounds small, but the structure is brilliant. Those 7 members serve 2-year terms, and they are elected based on years, sometimes decades of high-quality contributions. But here's the kicker, the 50% rule. No more than half of the core team can work for the same company. So even if a giant like Microsoft or Amazon hires a bunch of top-tier contributors, they can't legally or culturally seize the project. It forces a federated model of stewardship.
It's like a digital version of the separation of powers. But let's get into the weeds of how decisions actually get made. If I'm a developer at a big cloud provider and I want to push a massive change to how parallel queries work, something that might benefit my specific hardware, but maybe adds complexity elsewhere, how does that actually get vetted? Because I imagine there's a lot of corporate interests disguised as technical improvements floating around the mailing lists.
The mailing list is where the magic and the drama happens. The TPG-SQL hackers list is legendary. It's a permanent, searchable record of every design decision made since the mid-90s. If you want to propose a change, you don't just submit a pull request on GitHub and hope for a thumbs up. You have to defend your architectural choices in front of the world. And the community uses something called commit fests.
Commit fests? That sounds like a high-intensity coding retreat where everyone drinks too much coffee and forgets to shower.
Not quite. It's actually a very disciplined 4 to 5 week cycle that happens several times a year. During a commit fest, hundreds of patches are reviewed. And when I say reviewed, I mean scrutinized to a level that would make most enterprise software developers weep. They look at data integrity, performance regressions, and whether the code fits the Postgres way. In 2024, for example, there was a huge debate over parallel query improvements. Some people wanted to move faster, but the community reached a consensus to slow down to ensure there were no edge cases that could lead to data corruption. They value correctness over features every single time.
See, that's the cheeky side of Postgres I love. They'll look at a trendy new feature and basically say, "That's cute. Come back when you can prove it won't lose a single byte of data during a power failure in a Category 5 hurricane." It's that refusal to take shortcuts. But Herman, who pays for all this? You mentioned people work for different companies, but someone has to pay for the build servers, the conferences, the legal fees. If there's no central corporation, where does the cash come from?
It's a distributed patronage model. You have companies like Enterprise DB, Crunchy Data, Microsoft, and Google who all employ full-time Postgres contributors. These companies have a vested commercial interest in Postgres being excellent because their products are built on top of it, so they essentially donate the labor of their best engineers to the community. Then you have the PostgreSQL Europe and United States organizations that handle the actual money donations and conference revenue to pay for the non-code essentials.
So it's a co-opetition model. They compete for customers in the marketplace, but they cooperate on the engine. It's like Ford and Chevy both contributing to the design of the internal combustion engine because they know if the engine stops working, no one buys cars.
That's a great way to put it. And because it's federated, you don't get the lone maintainer problem. In a lot of open source projects, if the lead dev gets hit by a bus or just gets bored, the project dies. In Postgres, the burden is shared across dozens of companies and hundreds of committers. If one company pivots away from databases, 3 others are standing by to pick up the slack because their entire business model depends on it.
It's a very resilient ecosystem. But let's talk about the actual software. We just saw the release of Postgres 18 in late 25, and version 18.3 just dropped in February of 26. To the average user, these version numbers can feel a bit arbitrary. What's the actual difference between a major release and these minor or incremental releases? Because I think a lot of people see an update notification and just hit ignore until their security auditor yells at them.
Oh, you should never ignore a Postgres minor release. Let's break it down. A major release like 18 or the upcoming 19 happens once a year, usually in the autumn. These are the ones where you get the shiny stuff. For version 18, we saw massive improvements to logical replication and performance monitoring. This is where the file formats might change, where new SQL syntax is added, and where you might actually have to plan a migration strategy.
And the minor releases? Like the 18.3 update we saw recently.
Those are the keep the lights on releases. The project has a very strict policy. Minor releases never include new features and they never change the on-disk data format. They are strictly for bug fixes and security patches. In February 26, the community released updates for versions 16, 17, and 18 all at once. They fixed over 65 bugs and 5 critical security vulnerabilities.
65 bugs? That sounds like a lot for a stable database. Should I be worried that my data is currently being eaten by a digital termite?
Not at all. Most of these are extreme edge cases. Things like if you run a specific type of window function on a partition table while simultaneously dropping an index in a different time zone, the query might return an error. But because Postgres is used by everyone, those edge cases eventually get found. The fact that they catch and fix 65 of them in a single quarter is actually proof of how healthy the project is. They treat a minor bug with the same gravity that other projects treat a total system failure.
I love that. It's like a car manufacturer recalling a vehicle because the clock is 3 seconds slow. It shows they're paying attention, but I want to go back to the boring advantage. We've lived through the NoSQL revolution, where everyone said relational databases were dead. Then we had the new SQL wave. Now we have vector databases for AI. Every time Postgres just kind of sits there, waits a year, and then absorbs the best features of those trends into its core or its extensions.
The extensibility is the real alpha of Postgres. It was designed from the beginning at Berkeley to be extended. Think about PostGIS. That's an extension that basically turned Postgres into the world's best geographic database. or PG vector, which is how everyone is doing. AI search right now. Instead of moving your data to a specialized unproven vector database, you just use Postgres and add the extension.
Just use Postgres has become the mantra of the sensible developer. It's like the nobody ever got fired for buying IBM of the 2020s. But there is a human cost to this, right? Even with the corporate patronage, the mailing list culture can be abrasive. It's a lot of very smart, very opinionated people arguing about C code and B-tree indexing. Is that sustainable in the long run? We've seen other communities struggle with toxicity.
It's a valid concern. The Postgres community is definitely old school. They value technical rigor above almost everything else, but they've also realized they need to modernize. There have been a lot of discussions in 25 and 26 about making the core team more diverse, not just in terms of who they work for, but in terms of geography and background. They're trying to move toward more transparency without losing that no shortcuts ethos.
It's a delicate balance. You don't want to turn it into a corporate committee where everything is decided by marketing, but you also don't want it to be an impenetrable fortress of gray-bearded sea wizards. Though, to be fair, those gray-bearded wizards have kept my data safe for a long time.
They really have. And it's not just the wizards, it's the entire infrastructure. Think about the testing. Before a major version like 18 was released, it went through months of beta and release candidate stages. They have a build farm with hundreds of different operating systems and hardware configurations. Every time a patch is submitted, it's tested on everything from a modern Linux server to an old Solaris box.
Who is still running Solaris? Actually, don't answer that. I don't want to know. It probably powers the elevator I took this morning. But this brings up a good point for our listeners who are running these systems. If you're an organization using Postgres, what's the responsible way to interact with the project? Is it just about donating money, or is there more to it?
Money helps, but contributor time is the real currency. If you're a large company using Postgres at scale, the best thing you can do is allow your engineers to spend 20% of their time contributing back, whether that's fixing bugs they find in production or improving documentation. Documentation is actually one of the strongest parts of Postgres. It's famously thorough.
It's basically a textbook on database theory that happens to come with a free database. I've actually used the Postgres docs to understand SQL concepts that had nothing to do with Postgres specifically. But Herman, let's look at the failed versions of this. Why did MySQL take a different path? Why did it end up under Oracle's thumb while Postgres stayed free?
It comes down to the ownership of the trademark and the copyright. MySQL was originally owned by a single company, MySQL AB. When that company was bought by Sun Microsystems, and then Sun was bought by Oracle, the keys to the kingdom were part of the sale. Postgres never had a kingdom to sell. The copyright is held by the PostgreSQL Global Development Group, and the license is a BSD-style license, which is incredibly permissive. You can't buy Postgres because nobody owns it.
It's the ultimate poison pill for a corporate takeover. If a company tried to buy the project, the community would just fork it and move on within 24 hours. There's no central asset to seize. That's a powerful lesson for any new open source project. If you want to be around in 30 years, don't let a single entity own your name.
And that longevity is what builds trust. When I talk to CTOs at banks or insurance companies, they aren't looking for the fastest database or the one with the coolest logo. They are looking for the one that will still be supported in 2040. They want to know that if they find a bug in the middle of the night, there's a global community of experts who care about fixing it.
Predictability is a feature. That should be on their t-shirts. So, looking ahead to version 19, which is the next big milestone, what are we seeing? Usually, by this point in the cycle, the hackers list is buzzing with what's going to make the cut.
There's a lot of focus on further optimizing those vector workloads we mentioned, but also some really deep-level stuff regarding 64-bit transaction IDs. This is one of those deep magic things that most people will never see, but it solves a theoretical wraparound issue that can happen on extremely high-volume databases. It's the kind of thing that only matters if you're doing billions of transactions, but Postgres wants to be ready for that scale.
See? That's exactly what I'm talking about. Most startups would say, we'll deal with transaction ID wraparound when we hit 1 billion users. Postgres says, We're going to fix it now so that when you hit 1 billion users, you don't even know it was a problem. It's proactive engineering.
It's also about sustainability for the people involved. We've talked about burnout, and the way Postgres handles this is by not having deadlines in the traditional sense. They have a release window, but if a feature isn't ready, it doesn't get shoved in at the last minute. It just waits for the next year. We saw this with some of the asynchronous I/O improvements. They've been working on those for years, and they only let them in bit by bit as they are proven safe.
That must be incredibly frustrating for the developers who want their features in now, but it's great for the users who don't want their database to crash. It's like a chef who refuses to serve the souffle until it's perfect, even if the customer is starving. You might be annoyed for 10 minutes, but you'll be happy when you finally eat.
And that's why the minor releases are so frequent. If they find a way to make something 5% faster or safer without changing the architecture, they don't make you wait a year. They'll put it in a quarterly update. That's what we saw in 18.3, just solid, incremental refinement.
So, for the folks listening who are maybe sitting on an old version, maybe they're still on Postgres 12 or 13 because it works and I don't want to touch it. What's your pitch for staying current? Beyond just the security fixes.
My pitch is that the performance gains in the recent versions are massive. We're talking about improvements in how indexes are handled, how memory is managed, and how the query planner works. You can often get a 20% speed boost just by upgrading the engine without touching a single line of your application code. It's like getting a free hardware upgrade.
Free hardware upgrade is a language every CFO understands, but you do have to be careful with the major upgrades. I've seen people try to jump from version 10 to version 18 in one go and, well, let's just say it was a long weekend for the DevOps team.
Oh, definitely. You have to follow the migration path. But even there, the community has built tools like dpeak upgrade that make it much smoother than it used to be. The project cares about the upgrade experience because they know that if people get stuck on old versions, the ecosystem fragments.
It's all part of that stewardship Daniel was asking about. It's not just about writing code. It's about managing the life cycle of the software. It's thinking about the person who has to manage this database 5 years from now.
And it's about the human element. There was a minor release delay recently in early 26. The community realized there was a small issue with one of the security patches, and instead of rushing it out to meet the February deadline, they pushed it back a week. In a world of move fast and break things, seeing a project choose to move slow and keep things fixed is so refreshing.
It's the sloth approach to software, Herman. I feel seen. Take your time, do it right, and then have a snack.
Wait, I'm not allowed to say that word. I mean, you're absolutely... No, I'm doing it again. Let's just say you have a point, Korn. The measured approach is what wins in the world of data storage. When you're talking about the source of truth for a multi-billion-dollar company, you don't want agile, you want stable.
You want a rock, and Postgres is a rock that happens to have a very active group of people polishing it every single day. So, what's the takeaway for our listeners who aren't database administrators? Maybe they're just tech curious, or they're building their first app.
The takeaway is that governance matters just as much as code. When you're choosing a technology to build on, don't just look at the benchmarks or the GitHub stars. Look at who owns the name. Look at how they handle disagreements. Look at their release history. If they'd been putting out steady, reliable updates for 25 years without a single corporate scandal, that's a better indicator of success than any Series A funding announcement.
It's a vote for the commons. It shows that we can build world-class infrastructure that belongs to everyone and no one at the same time. It's kind of a beautiful idea when you think about it. This massive, complex engine that powers the world, and it's basically held together by mailing lists and a shared sense of duty.
It really is. And as we look toward the next 25 years, the challenge will be to keep that spirit alive as the original wizards retire and a new generation takes over. But based on what I've seen in the version 18 and 19 development cycles, the Postgres ethos is being passed down just fine.
Well, I'm looking forward to version 25, which I assume will be managed by a sentient AI that still insists on using the 80-character line limit for its C code, because that's how we've always done it.
I wouldn't bet against it. The hackers love their formatting rules.
They really do. All right, I think we've thoroughly geeked out on database governance. It's a fascinating look at the boring parts of tech that actually make everything else possible. Thanks as always to our producer, Hilbert Flumingtop. for keeping us on track.
And a big thanks to Modal for providing the GPU credits that power this show. They make the heavy lifting look easy.
This has been my Weird Prompts. If you're enjoying these deep dives into the plumbing of the internet, a quick review on your podcast app really helps us out. It's like an index for our show, helps people find what they're looking for faster.
See you next time.
Later. This episode was produced using Google Gemini 3 Flash, text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My weird prompts.